Hey, hey, you ready to actually fill out some truth tables? Well, here we go. What is a truth table? Well, basically what it sounds like. It's a table. It's got rows and columns, and you set it up with truths and falses to help determine whether a given statement is true or false, or under what conditions is it true or false. So a full truth table is going to give you every possible condition and then every possible result. Because the first columns, first 1, 2, 3, how many columns you need will list all your possible true-false arrangements, and then how many of those first columns you need depends on how many simple statements your statement breaks down into. And then you follow that with new columns to gradually work your way through your statement and figure out the truths and falses. And there's a hierarchy and there's definite rules. The key here is to not think things through too hard, because if you do, it's easy to get overwhelmed and get lost. Instead, follow the rules. Learn the rules. That's the key. Every student who messes these up hasn't bothered to follow the rules and learn the rules. That's all you have to do is, nothing else. There's nothing else to it. So it's not rocket science. It's just memorize the rule, apply it, you're good to go. Okay, and just a really quick refresher on the hierarchy. We covered this in the last lesson, but a quick refresher. If you have parentheses, you tackle those first. And whether you're inside parentheses or outside parentheses, you look at negations, then your conjunctions and disjunctions, then your conditionals, and finally your biconditionals. And whatever it is you evaluate last, that's the type of statement you have. So if the very last rule you have to apply is the one for disjunctions, then your entire statement is considered to be a disjunction. Doesn't matter what else is in there, just whatever you do last is what that overall statement gets categorized as. Okay, now as I mentioned, you can have 1 or 2 or 3 columns to start, depending on your situation. If you only have one column, it's because you have one simple statement and you just need to put true and false. 2 rows, true, false. But if it breaks down to 2 simple statements, then this right here shows you how to get started by putting 2 true and 2 false under P, and then TF under Q. You've got all your scenarios covered. True, 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 false, false, true, false, false. There are no other true, false scenarios if it breaks down to 2 simple statements. If it breaks down to 3 simple statements, under P you put 4 true, 4 false. Under Q you put 2 true, 2 false, 2 true, 2 false. And under R you put TF, 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 TF. And by doing that, you have set up all possibilities for PQR. All possible combinations of true, false. So follow that pattern. And as you might note, the pattern is related to binary, or 2 to a power. 2 to the 0 is 1. 1 true, 1 false, 1 true, 1 false. 2 to the first is 2. 2 true, 2 false, 2 true, 2 false. And 2 squared is 4. 4 true, 4 false. If you had a PQRS, then you would have to start with 8 true, 8 false, and so on. So, I don't know, just that's a little nerd, and that's a little nerd fact for you. Alright, so that's how you start it. So every time you go to do a truth table, you're going to start it one of those ways, depending on how many simple statements you're dealing with. And then from there, you start breaking down your statement, follow the rules. Remember, negations change your truth values. So if under the P column it's 4 true, 4 false, the negation P, or not P column, will be 4 false, 4 true. If one was true, the negation's false. If one was false, negation's true. Automatically for negation. And then conjunction. Remember, conjunction was the statement joined by the word and. When you think about the word and, think about what it means. And it'll help you to remember the rule here. So this is your first rule you're going to have to really remember. I don't think negation is something you're going to have to sit there and stress about. It's pretty straightforward and easy. But conjunction is the first rule you're really going to have to think about and make sure you commit to memory. I like to use this scenario because it's for my son. It's kind of popular, although he's getting a little older now and he's outgrowing this scenario, but whatever. Let's say I tell my son that we will get a kids meal and go to the park after school. So I tell them that when I'm dropping them off at school. Maybe I'll be like, you know what, later on today I want to pick you up, we're going to go get a kids meal and go to the park. Notice the use of the word and. And is a conjunction word. Remember, you could also have but, however, nevertheless, but frequently it's and. But, however, nevertheless, they're going to follow the same rules. That's a conjunction word. And if I tell my son that, he is expecting both to happen. So, if both happen, if both are true, then I'm not a liar. If I pick him up from school, and if I go ahead and get him the kids' meal and take him to the park, then I'm not a liar. But as soon as there's a false, as soon as I back up on my word about one or the other or both, let's say I pick him up, don't get him the kids' meal, but still take him to the park, well, I'm a liar. It's like partial liar, but I'm a liar. If I don't get him a kids' meal but take him to the park, or if I do get him a kids' meal and don't take him to the park, either way, I'm a liar. And if I pick him up and don't do any of those, I'm really a liar. I guess is there degrees of lying? White lies versus big lies, whoppers. Either way, in the rules of logic, it's all black and white here. It's all true, false kind of thing. It's if there's a falsehood with an and, if I back up on anything I've stated in my and statement, then the final result is false. So that's how it works with conjunctions. Okay? Alright, let's look at an example or two that you might see when you're doing your work. One example, they might say construct a truth table for the statement. And you might be given a statement like P and not Q. And you're asked to construct a truth table for that. Okay, you just have P, Q, so you know you're going to set up your truth table with the two columns to start. Under P, you put 2 true, 2 false. Under Q, you put TF, TF. And I would suggest using lined paper when you do this to keep everything straight. I tried to find a good template for lined on my slide here, but I just couldn't find one that I was happy with. Alright, and then according to our hierarchy, negations have to be done first. So let's do the not Q. So that not Q, negation Q takes the Q column and changes it. So if Q is true, now it's false. If Q is false, now it's true. Then we take what we have from the P column, what we have from the not Q column, and apply the AND rule. So we have T and F. Remember with AND, they both have to be true to be true. I have to take him to get a kid's meal and I have to take him to the park in order to be fully truthful with him and not break his trust about my word. In this one, in this first row, we have a T under the P column and an F under the not Q column. So that's false. Second row, we have a true under P, a true under not Q. Both are true, so the entire statement is true. Third row, we have a false and a false, so that's definitely false. Fourth row, we have a false and a true, so that's false. And this right here is our answer column. This is the last column we did. This statement is a conjunction. The last thing we analyzed in the columns was the rule for conjunction. So statement is a conjunction. And so if you have a statement where only when the P is true and the not Q is true do you have a fully true statement. Otherwise it's false. Alright, let me show you an example with a negation outside parentheses. This is kind of tricky. Negation, parentheses, not P, and not Q. Okay, if you have parentheses, you got to tackle the inside first. So setting up our truth table, we see P's and Q's in our symbolic statement here. So we go ahead and we set up the PQ columns in the standard way. Under P it's TTFF. Under Q it's TFTF. Now we have to do, in the parentheses, we have to do negations first. So we need to go ahead and do a not P column and a not Q column. Okay, so P column is TTFF. So not P is FFTT. Q column is TFTF. Not Q is FTFT. Once we have those in the parentheses, we have to do not P and not Q. Not P and not Q. False and false is false. False and true is false. True and false is false. True and true is true. So you're looking at the not P column, the not Q column. As long as there's a false in there joined by the and, it's false. The only time it's true is if both are true. Then finally, that's the inside the parentheses, and then working our way out now, we have a negation outside the parentheses. So that's like saying it is false that, not P and not Q. So you take the not P and not Q column we just did, and you negate that. So true, 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 false. So that's how you handle negation outside the parentheses. Do what's in the parentheses, and then the final result from that gets negated. Okay, and then the other one covered in this lesson is disjunction. That's the ors. Now if I say, after school, we will get a kid's meal. Or go to the park. Son is expecting at least one of these to happen. If both happen, awesome. Since I said or, this is the inclusive or I referred to last lesson. Since I said or, this or is implying we'll do one or the other or both. If neither happens, I'm a liar. And the only situation with or where I'm a liar is right here. In the other three, I was not a liar. Because here, P's true, Q's true, that means I went ahead and gave him the kids' meal and took him to the park. So with the or, he's super happy because he's only expecting like maybe one of those to happen. And I went ahead and did both. Woo, yippee. True, false. Got the kids' meal, didn't go to the park. That's okay because I said or. So as long as, getting the kids' meal, that's one of them being fulfilled. False, true, that's not getting a kid's meal but going to the park. That's still okay too because I gave him one of those. But false, false means neither kid's meal nor the park. Now he's unhappy and he doesn't know if he can trust my word. So that's where I become a liar. Alright, so let's show an example with an or in there. Let's see here. Let's do one where we have to have 3 columns. We haven't seen one of those yet. Alright, we got P or parentheses, not Q or R. Okay, so I see P, Q, R, so that tells me I got to set up my 3 columns to begin with. I'm going to put 4 true, 4 false under the P column. I'm going to put 2 true, 2 false pattern under the Q column. I'm going to have 8 rows. And then I'm going to have the 1 true, 1 false pattern under the R column for 8 rows. Okay, so that's the initial setup. It's that way anytime you want a PQR. This statement has parentheses, and inside the parentheses there's a negation that has to be tackled first. So not Q. So I'm going to take the Q column and negate it. So the Q column had 2 true, 2 false pattern. Not Q column is going to have 2 false, 2 true pattern. Then inside the parentheses, we still have that or symbol, not Q or R. So we take the not Q column, the R column, and apply the or rule. The only time or is false is if both are false. I promise one or the other. If I don't do either one, that's when I'm going to become the liar. As long as I do one of them, though, I'm good. So I have false or true, that's true. False or false is false. True or true is true. True or false is true. False or true is true. False or false is false. True or true is true. True or false is true. Okay, so that handles the parentheses. Then outside the parentheses we have P, which is already covered, or, and then that parentheses result. So we got to take the not Q or R column we just did and compare that with the P column from over here and apply the or rule. True or true is true. True or false is true. True or true is true. True or true is true. False or true is true. False or false is false. False or true is true. False or true is true. And there we go. There's our answer column. And since the last thing we did was a disjunction rule, the entire statement is a disjunction. Whatever that last rule you applied in that last column, that's the type of statement you have. And there you go. So there's an example, too, of the PQR kind of truth table. Now, you're not always going to have straight up symbols. Remember, the symbols are representing words. So you could have examples where everything's in words and you got to figure out, well, how am I going to do this? You have problems like that in your homework. Like translate each statement into symbols, then construct a truth table for each compound statement and indicate under what conditions the compound statement is true. All right, let's say you have something like P Tanisha owns a convertible. Let's say you have something like Q, where Joan owns a Volvo. Let's say you're given this statement. Tanisha owns a convertible, or Joan does not own a Volvo. Tanisha owns a convertible, or Joan does not own a Volvo. All right. Before we try to figure out the truth values here, we need to put things into symbols and then do our truth table. It's so much easier when it's in symbols. So even though we have words to start with, let's convert to symbols and use those, and then we can always convert back to words if necessary. Okay? So Tanisha owns a convertible. We already designated that to be P. Or, disjunctive V shape there. Joan does not own a Volvo. Well, Joan owns a Volvo is Q, so Joan does not own a Volvo is not Q. So we're going to do a truth table for P or not Q. And this will show us the conditions where the compound statement is true. So we'll start with PQ columns. It's just the two, so you just need 2 true, 2 false under P, and then true, false under Q. Then I need a not Q, because I need negation before I can do the OR. So if Q is TF, TF, not Q is FT, FT. And then P or not Q. P, T or F is true. T or T is true. F or F is false. F or T is true. So this column right here tells us the condition, will help us to see the conditions where the compound statement is true. The compound statement is true when P is true, not Q is false. When P is true, not Q is true. And when P is false, not Q is true. So those are the conditions where the compound statement is true. Okay, I want to show you one more example before we wrap up and wait till the next lesson to see how to do truth tables for conditionals and biconditionals. Now, you don't always have to do a full truth table depending on how the problem is worded. You've actually got some problems where they say determine the truth value of the statement if, let's say you're given that P is true, Q is false, R is true. So you're given that. So if you have a statement like P and parentheses not Q or R, you do not have to do an entire truth table because you've been told what the truth values of P, Q, and R are. Like this would be one row of the truth table that's TF, T across. So what you could do is just use your hierarchy and start breaking this down. Okay, first row, let's see. We know we have to tackle inside the parentheses first. Negation of Q is going to be true. and R is true. You know, Q is false, so negation of Q would be true. T or T is true. Then we know P is true, so you're trying to figure out true and true. True and true is true. So you don't need a full truth table to see, because you're told what the conditions are to begin with. And you're trying to see, well, what's the truth value of a statement with those conditions. So that, you know, that it'll specify on those problems what P, Q, and R are. Ooh, that looks like fun. Don't let brackets and things throw you. Let's say you have a problem like that one where it's parentheses P or not Q. And then it's and brackets, negation, parentheses, P and not R. Close parentheses, close brackets. Alright, think about brackets as just being another type of parenthesis. When you have parentheses inside of parentheses, you're going to see brackets. So that way you can tell what encloses what. So innermost parentheses first. You know, when you have parentheses inside of parentheses, go inside the innermost ones first. Alright, in this one, we have P is true and not R. So if R is true, not R is false. That's T and F. That's going to be false. And then the negation of that is true. Then you have, over here in these parentheses, you've got P is true or not Q. Q is false, so not Q is true. So T or T is true. And then you got T and T, which is true. So you can just write out the statement like that and then work out everything underneath. Like go inside your parentheses and start working out everything underneath until you run out, like I did here with the true. Go inside these parentheses, work out everything underneath until you run out. Then finally, like out here I had the and joining the two, so I had to apply the and rule, and it's true. So that statement's actually a conjunction because the last thing we did was apply the and rule. So in this one, both statements are conjunctions. The very last thing we had to apply was the and rule. So that makes, even though the statements had ors and negations and stuff in them, it's whatever that last rule is. That's what tells you what kind of statement to categorize it at. Alright, well, I hope this is enough examples. If not, you know where to find me. Have fun. Truth tables are great. Learn the rules, follow the rules, you'll be okay. And then tune in again in the next podcast to wrap up the rules for conditional and biconditional. And that's where it starts to get really fun, because once you know all your rules, then we're going to start analyzing statements and arguments. Alright, thank you for joining us, and we'll see you again soon.